We are talking, we're in the first unit. The unit is numbers and algebra. There's two sections of this. This first section covers number sets and percent error and significant figures, scientific notation, kind of some stuff that maybe you already have dealt with at some point in time. And so that's pretty much what the first section of numbers and algebra is. Okay? Just a heads up, probably in 2 weeks, you guys are going to have your first test. Okay? And it's going to cover basically what we do starting today, and we'll probably wrap it up by next Thursday. Okay? So it's not a big section. Okay? So be ready for that probably in about 2 weeks. Okay? So today you guys are going to be able to classify numbers into sets and determine approximations. Some of this will be familiar. Okay, I hope it's familiar. All right, it should be. So if I just scared you with the whole test comment, as when I flip through, you're gonna be like, oh, no. Okay, so let's start. There are different numbers that belong to different number sets. Okay, you have your real numbers, and that's the symbol associated with real numbers. You have your rational numbers, and the symbol associated with rational. Integers, and the symbol associated with integers. And natural numbers, and the symbol associated with natural numbers. Now we're going to go into each of these in a little bit more detail, but these are the different sets that you'll have to deal with, and the symbol that goes along with them. Raise your hand if you've seen these things before. Okay. Good. So we're going to go into them a little bit more in detail. Okay. So the first one is your natural numbers. Okay, these are the numbers that you use to count with. Okay, the ones that you also use when you're trying to put things in order. 1, 2, 3, 4, 5, 6, and so on and so forth. What's another way you can represent these types of numbers? What's another way? Like another way to say them? Whole numbers. Huh? Whole numbers. Whole numbers. Yes. Whole numbers. And what are whole numbers? Let's describe another way. See how you can describe whole numbers. With an adjective, perhaps. No, not rational. Not rational. That's like another way to classify these numbers. But another natural numbers, they are like whole numbers. What else? What other kind of numbers are they? Positive, right? Are they all positive? There was no negatives in that list, right? Okay. So they're positive whole numbers, so no decimals, no fractions, nothing like that. Okay, the ones that you use to count 1, 2, 3, 4, 5, 6, all the way up. All right. And so when you're finding the value of these expressions, this is an example. When a equals 5 and b equals 7, determine if they're natural or not. Here, what are you going to do here? Literally.
Add 5 plus 7.
Add 5 plus 7, which is 12. Is that a natural number? Yes, it is. Okay. Now this x. Let's take a pause. Let's talk about this x. What does this mean? Multiplication. And what do you need to know? Okay, in the IB program, in the phone program, certificate program, whatever, IB is international. Okay, across the water, they don't use that multiplication dot when you're talking about multiplication. Okay, that dot actually represents something completely different than just regular, 5 times 7. So the way you're going to see multiplication is going to be with the binary x, like old school, like when you first learned about multiplication, it was the x. That's what you're going to see. Or you're going to see just them put together like this. Okay, so you won't see the dot. If you see the dot, that means something completely different, which we don't do in studies, we do in the other class. So you'll never see the dot. So 5 times 7 is
35.
35. Is that a natural number?
Yes.
Yes, it is. Okay, so far so good. Yep. All right, a minus b is going to be what? Is that a natural number? No, it's not. Why? Because it's negative, and natural numbers are only your positive numbers. And then b minus a is going to be what number? 2. Natural? Yes, it is. Okay? You guys got that, yeah? Okay. The next type are your integers. That's the symbol. What's the symbol for integer? What does it look like? It's a Z. It's a Z. Okay? It is a Z. These are your positive and negative numbers plus 0. Okay, so all your negative numbers, 0, and all of your positive numbers. Kind of like, you know, when we used to do the old school number line. Okay, then we always put the whole numbers on that number line. That's basically where they're coming from, okay? Alright. We're gonna solve these equations, state whether the solution is an integer or not. Nothing too complicated. I have nothing but the utmost confidence in your abilities to do this, okay? How do I let me take a volunteer. Don?
X equals 6.
How'd you get that?
By doing 11 minus 5.
So you subtract 5 for both sides, yes?
Yes, ma'am.
Okay. I'm just trying to get in that whole, you know, showing your work process. Even some of the simplest that, because I would hate for you to be rushing through and for whatever reason put 5 down and not 6. You know, is this an integer or not? Yes or no? Yes, it is. It is a positive whole number. So we're good. What about over here? Somebody different. Solve this one, solve this one. Divide by -3 on both sides, and then your answer is going to be what? You don't have to do. You don't have to go all that deep. Just what is it? Three and some change, or we could just leave it as -10/3. Okay, it's okay. And honestly, sometimes it's a lot easier to leave the fractions as they are because that is exact instead of using the decimal approximation. Okay, so you could even probably just depending on how you round. All right, so we leave it as a fraction -10/3, and is that an integer or not? No. Why not? Say again. It's not a whole number. It is a fraction. This right here, this -10/3, is actually classified as a rational number. Rational numbers are the numbers that can be read as the quotient of two integers. What is another word for quotient? Division, divide. Anything else? Y'all never heard another word for quotient?
Dividend.
That is what you get when you actually perform the quotient. Another word for quotient is a fraction. Fraction. And that's one thing that you really want to look at when you think about rational numbers. Can it be written as a fraction? That's how you'll know if it actually fits that category. Okay, can you write as a fraction? 7 can definitely be written as a fraction. How do you think? 7/1. Okay? And even though, yes, 7 itself is a natural number because it's a positive number, it's also classified as a rational number because you can write it as a fraction. Okay? Which means that -3 can be written how? -3/1. Okay, even though it's an integer, it's also a rational number. So certain numbers can actually have more than just one particular classification. It could be a natural number and a rational number. It could be integer and a rational number. It could be many different types. 0 can also be written as a fraction because we all know 0 divided by anything is just 0. What about -1.5? That's a decimal, but it actually can be converted into a fraction. What's the fraction of -1.5? Okay, almost there. That's a mixed number. Give it to me as an improper fraction. 3/2. Very good. -3/2, yes. And even though, this decimal here, you shouldn't say, oh, it's a decimal, it's not a rational number. It's a decimal that can be converted into a fraction. And because it can be converted, it is a rational number. Okay? So even any decimals that can be converted to fractions are rational numbers. So like this last one right here, 0.33333 repeating, what's that? What's that as a fraction? Say again? It's 1/3. Okay? So all of these are examples of rational numbers, okay? It's any number that can be written as the quotient of two integers. 7 is an integer, 1 is an integer. -3 is an integer, 4 is an integer, all these are integers. Okay? So, let's look at this example. It says express already know what 0.3 repeating is as a fraction. What is that? 1/3. So this is technically 1 1/3. Now we're out of middle school here. In elementary, we don't really deal with mixed numbers up at this level. Okay, they're dealt with as improper fractions. So how we turn this into an improper fraction? Multiply the 3 and the 1, and then add the 1 to get 4/3. We keep the denominator the same. So that's the first part. Okay? Yes. Could very well be a question just like this, and then they give you something a little bit more detailed. Okay? And this is how you know that, it starts off simple and then they hit you with it. Okay? Hence. This word you will see multiple times. What does hence mean? I know it's not English class, but what does hence mean? Okay, so what's like another word you can use instead of hence?
Reasoning.
Reasoning? Not quite. Not quite. Another word? Elaborate, so go further. Possibly. Yes. So, like, if going a step further, hence basically means, okay, continuing this, continuing that, continuing what you just did. Okay? So basically, hence is like, all right, what you just did, finding out that 1.3 repeating is 4/3. You're going to use that to calculate what 1.3 repeating plus 4/5 is. So hence basically means that the answer that you just found, you're going to use it to answer this question. Okay? And remember how the other day I was talking about MAR schemes and follow through? If you were to get part A wrong, but you use whatever answer you got to answer part B, you're not going to be penalized twice. Okay? As long as you show the proper steps. Alright? But that's right, so we're good. Okay, so we have 4/3 plus 4/5. Now, who remembers how to do this by hand? The butterfly. If you cross through the classroom, you know about the butterfly. If you don't, this is it. You multiply 4 and 5, which is what? 20. You multiply 4 and 3, which is 12. And because you're adding the 2, you'll add at the top. And then at the bottom, what do? You multiply 3 and 5 to get 15. Now, I don't know how she makes a butterfly of that, but she does. I'm not quite sure, but.
And then she goes like this.
Like, boom.
Wait.
Boom.
Yeah. And then that little just, there we go.
Go down. What's 20 plus 12? 32 over 15. Now, it says give this as a fraction. And the reason why it says that is because in IB studies, you are allowed to use your calculator all the time. At no point in time are you ever told, no, you can't use your calculator, okay? I just asked you to do it by hand just to see if, learned anything. That's okay? But I'm actually going to show you how to use this calculator here and how you can actually do this, okay? Because that calculator is one of those types of calculators that, it can do a lot of different things. So let's go ahead and open up our calculator. And you're probably like, okay, I need to turn this thing on. There's literally an on button. Okay? You press it. It's like a computer. Alright? Now, we're actually going to add those two fractions together. 4/3 and 4/5. Okay? Now, that fraction 4/3 is the same thing as saying 4 divided by 3. So when you want to type in a fraction, you literally are going to have to do 4 numerator divided by denominator. So let's do that. 4 divided by 3. And then we're going to add 4 divided by 5. So we got to add 4/5. Okay? Now, enter is just like equals. So you press enter and you get this decimal. And the problem said, write it as a fraction. Now, I'm going to do 2 of my favorite things that I love about the graphing calculator. The first one is how to take any decimal and convert it to a fraction. Okay? Now, I know my decimals pretty well, but sometimes I don't know at which decimal turns into which fraction. So this is the best trick ever, I think. You see this button called math? It's right simplifies for you. Yes.
Well, it'll do the exact same thing if you just go down the decimal for a fraction as well, right?
But remember, a fraction is just, you're just dividing your numerator from your denominator, so you'll get the decimal form. Let's do another one. Let's do 0.125. How do I convert that to a fraction? What do I press? Math, and then enter. And it's 1/8. So there you go. You can convert any decimal into a fraction. And that way you can also see that certain decimals are going to end up being rational numbers. Because if our calculator can convert it into a fraction, then it's a rational number. But if you try to do it and it doesn't convert into a fraction, then it's not a rational number. Only decimals that can actually be converted to fractions are rational numbers. Alright? So, a number is rational if it can be written as a quotient of two integers. It's kind of like a summary of what I just said. It can be written as the quotient of two integers. And what's another word for quotient? Fraction. Dividing. Its decimal expansion is finite. Anybody know what finite means? It's not infinite, which means it will end. Okay, so a decimal expansion is finite. So an example of that would have been the 0.25 example I just did, or 0.5. Okay? Or it's going to be rational if its decimal expansion is non-terminating but has a reoccurring digit. That basically means that it doesn't stop, but it's one of those like 0.33333, repeating, or 0.1666666, like that. Those types also are rational numbers. Okay? Alright? It says for each expression, we got two different types of expressions. We're going to calculate the value with x is equal to -4 and y is equal to 1/2. We're going to get some practice with this graphing calculator here, okay? I want you guys to get comfortable. Only way you're going to be able to do that is if you practice. And then we're going to say whether or not A and B give us a rational number or not, and we're going to justify our answer, okay? So if anything, make sure you at least get down the two expressions that we're going to do. For part I, you just need to put x equals -4 and y equals 1/2, and then 2, rational or not. You want to shorthand it, okay? So for A, if x is -4 and y is 1/2, that literally means that we're going to plug in, right? And then we want to square. Now by all means, you don't have to use a calculator if you don't want to, okay? But I do want us to try to get some practice with the graphing calculators. And so, let's go ahead and pull this up. Alright, so let's do this in our calculators. So we're going to do -4 plus a 1/2. Alright, and we do want to make sure we put the parentheses around it because we are going to square whatever that sum is. So the parentheses, everybody see where it's located? Where is it? Right where? Over the A. Yes. Okay, and if you want to, you can press clear and it gets rid of your screen, what we were working on before. Okay, if you want to clear screen. I don't suggest you clear every single time. It's the next problem, clear it then. Alright? So parentheses, -4. Big difference between this one on the gray button and this one down here. They look similar, but they're two different things. The one on the gray means what do you think? Subtraction. This one means subtraction. The one in the white is actually the negative. Okay? You will get an error message if you try to do -4 as a -4. It's going to come back like, syntax error. Plus 1/2. How do I write that fraction in again? 1 divided by 2. You don't have to worry about putting parentheses around the 1/2 here because the calculator automatically goes to order of operations. So it's going to do that 1 divided by 2 before it ever adds to the -4. Close it off. Now we have to square this whole fraction. There's a button. It's diagonally from the 7. You probably can't see it up here, but you can definitely see it on yours. It says x squared. click that, it automatically does the 2. It saves you like an extra keystroke from doing this button here and then pressing the 2. Because this button like does, oops. Delete that. You see what I'm doing here? Okay? Say you make a boo-boo and you gotta go back. Okay? Just press this arrow over and it will allow you to, go back as far as you need to get rid of whatever boo-boo you made. Okay? And you can press delete to delete something that you added in that you didn't mean to, like I just did. Don't press clear. Clear gets rid of everything. You gotta start over. Okay? Delete is just like the keyboard. Okay? Yes. Here's our answer. Okay? Is that a rational number? Can it be converted into a fraction? Do it. How do you convert it to a fraction? What do you press? Math. Answer. Answer. It is 49/4. Now, it didn't specify that you had to put it as a fraction or anything like that, but I mean, hey, this kind of just verifies that yes, this is a rational number because it can be written as a fraction. Okay? And this is also how you can justify it. Because when you do your calculator, you get 12.25, which is the fraction. This right here shows the work. This justifies that this is a rational number. Because it can be written as a fraction. If you want to write it out, it can be written as a fraction. You can do that too. There's nothing wrong with overkilling your explanation. Okay? Let's do B. What does the symbol mean? Square root. So we're going to square root -4 minus 5 and divide it by 1/2. We're going to do this in our calculator. Just out of curiosity, what's -4 minus 5? Okay, so to save a little bit of time, a little bit of less headache, can we just do -9 instead of -4 minus 5? Okay. All right. Square root. Do you see it on your calculator?
Yes.
You gotta press second and then the x squared button. Anytime you press the second button, any of the blue options are available. So the square root is located where the x squared button was. And now let's type it in. -9 divided by 1/2. Careful. Remember I said the calculator does order of operations, which means it does it like to the T. If you don't put 1/2 in parentheses, you're going to get a completely different answer. Okay? Let me show you. If you just did 1 divided by 2, the calculator is going to read take -9 divided by 1, which is -9, then take that answer and divide it by 2. Then take the square root. We don't want the calculator to do that. We want it to literally do -9 divided by the fraction 1/2. Okay? So, include your parentheses around the 1/2 so the calculator knows you're dividing -9 by 1/2. And click enter.
Gives you an error.
It's an error. Why do you think it's an error? No, you can't divide by fraction, but what, Scott? It's a negative under the square root. And you cannot take the square root of a negative number. So is it a rational number? That's the justification. It's not rational, and there is no solution, which is nothing but a circle with a slash through it, like an empty set. That's your answer. We don't worry about imaginary numbers in IB studies. We do not worry about imaginary numbers in IB studies. Questions? About a lot of stuff. Last one is your real numbers. It's the set of all rational and irrational numbers together. Now, basically, if a number is not rational, it is clearly irrational. Okay? Those are your problems. Those are your numbers like pi and square root of 2. Square root of 2 is not a perfect square, is it? No, it's one of those decimals that don't repeat themselves. So that's why it definitely doesn't fall into the rational number category. And pi is the same way. Pi is a decimal that continues on and on forever. We do not use the 3.14 in IB. We use the pi button. It's there, so we use it. So this is a summary of basically everything that we just talked about in like a Venn diagram format. We don't worry about your whole numbers. Okay, in IB, whole numbers are basically your natural numbers in zero, but that's already taken care of in the integer category. So we just deal with natural numbers, which is what symbol? What's the symbol for natural? N. Okay. What's the symbol for integer? C. What's the symbol for rational? Q. And what's the symbol for real? R. The only symbol I did not talk about was rational, and that's basically like an eye with a shadow, I don't know what that's called, blocked centerpiece. Okay? And anything that's not rational is irrational. Okay? But no matter what, all of those are real numbers. This is for you, if you want to. This is the visual there. And what we're going to do is we're going to practice a few numbers. I'm going to give you a few numbers. I want you to basically tell me what set they fall under. Now remember, some numbers can be more than just one thing. Because if a number is natural, it's also an integer, it's also a rational number, it's also a real number because it's inside of all of these other sets. Okay? If a number is rational, then you also know that it's real. Okay? And so on and so forth. So I'm going to give you a few numbers, and I want you to, on your whiteboard, I want you to write the symbol of what number set it falls into. We're looking at these five. We're looking at these five. Okay? So, alright, so say you were given a picture of a Venn diagram, and you had to take the numbers that were given to you, you had to fill them into the Venn diagram. Okay? 5 would go in the natural number circle area because it is natural, but it's also embedded within these other 4 categories of real, rational, and integer. Okay? So here's the next one. It's a -1/2. A -1/2. Tell me what symbol they are. Rational category. -1/2 is a rational number, which means it is also real. Real. Yes. Okay? Raise your boards. Give you another one. This one's a little tricky. -√64. That's the next one. Where would I place it in my Venn diagram? What set does -√64 belong? It's 8. So this right here actually equals a -8. Is a positive number? No, so it's not an integer. It's a negative number, it's not a natural number. It is a negative number and it is a whole number. So it falls in the integer category. So it should be Z as well as Q because any integer can be written as a fraction and it is R. Okay? Last one. Pi is an irrational number. Okay, because it's decimal. When I talk about 3.14, that's not pi. That's a rounded approximation of pi. Pi is 3.1415, whatever. Keeps on going. Decimals don't repeat each other. There's not a particular pattern with those numbers after the decimal. So that's why it's irrational. If it's not rational, it has to be irrational. And no matter what, it's a real number. It is a real decimal. So that's why it's also real. So it's I as well as R. So think of it like this. Okay? If it's a positive whole number, it's all of them. Natural, irrational, natural, rational, integer, and real. Okay? If it's a negative number, you know it's an integer. If it's a fraction, it's rational. And of course, I'm talking about, in all the ones above it. And if it's not rational, it has to be what? Irrational. And no matter what, every number is that you're going to deal with in studies. Okay? All right. Those are the types of number sets that you'll deal with. Okay? We're going to move forward. We're going to look at approximations. Okay? Approximations. Exactly what negative is. Okay? We're going to be dealing with rounding. All right? So, same sheet, same notes, just kind of like making like a like title. We're dealing with approximations, still the same unit. The numbers in algebra. Rounding. No one should have to write this down. We're just reviewing here. Okay, now if you never knew, it's totally fine. Write it down. I'm hoping that everybody remembers that when you round up, if it's 5 or higher, right? And then you round down or you keep it the same number if it's less than 5, right? And DP does not stand for diploma program. It stands for decimal place. Okay? So 1 DP is 1 decimal place. We all know that's the nearest 10, right? 2 DP is nearest 100. 3 DP is 1,000. 4 DP is 10,000. Okay? So if I gave you a number like 12.45 and I asked you to round it to the nearest 10, you were going to tell me what? 12.5 because the nearest 10th is right here and that 5 is going to tell me to round this bad boy up. Right? Okay. So we're good with that. Let's see. Whiteboards. No paper. Not needed. Whiteboards. I want you to tell me the answer to A and the answer to B. I'm going to give you 1 minute. Answer to A to 2 decimal places. Answer to B to 1 decimal place on your whiteboard. All right. So 2 decimal places. That's a 1, 2. Oops. 2 decimal places. That's 1, 2. Am I going to round that 4 up? Yes, it's going to end up being 10.5 because that 5 tells us that we round that 4 up. 1 decimal place, that's right here. Is that going to stay at 0 or is it going to go up to 1? It goes up to 1. It goes up to 1. All right? Because that 6 tells us that we have to round up. But that's not my biggest concern. Okay, I'm hoping that you guys have been able to round for a while. This is my biggest concern. It's significant figures. This entire page is important. Please write it down, including the part that's in the blue. Significant figures, okay? This is really how you're going to be rounding mostly in IB. And unless they tell you specifically how to round, you always default to 3 significant figures, no matter what, okay? Now, the rules for significant figures. All non-zero digits are significant. So in the example of 2578, every single one of those is considered a significant figure. Okay? Zeros that are between non-zero digits are significant. I'm sorry I had this blocking, but there's a 4 after that 0. Okay? Zeros between non-zero digits are also significant. So this 20,004, every single one of those zeros are significant because they're in between 2 non-zero digits. So this right here is an example of 5 significant figures. The first one was 4 significant figures. The next one, zeros to the left of the first non-zero digit are not significant. This is one where students tend to have a little bit of difficulty with because they want to say, oh, well, after the decimal point, that's my first significant figure. No, it is the first non-zero digit. Okay? So your first non-zero digit would be the 2. So this will be your first significant figure. 3 would be your second. Did everybody see that? Okay? And the last one, zeros placed after other digits to the right of the decimal point are significant. So in this case, the words 0.100, those zeros after that 1 are significant because they follow a non-zero digit. Okay? So you start your count for your significant figure at your first non-zero digit. That's the easiest way to figure out where exactly you round. Okay? So we're going to look at these 3 examples and we're going to look at them together. And I'll probably give like another example too, just to make sure that the point is across. Okay? So the first one says to write down 24.31 correct to 2 significant figures. SF stands for significant figures. Where do we start our count? What's our first significant figure? The 2. So this is 1, and this is 2. Okay? So we're going to stop there. But the rules for rounding still apply. If the number after where I'm supposed to stop is 5 or larger, I'm going to have to round up. But since it's not, my answer is just going to be 24. All right? That is correct rounding to two significant figures. We okay? All right. This one, it says write down 1,005 correct to three significant figures. Where do we start our count? At 1. So here's my first significant figure. Here's my second. Here's my third. So technically, I'm gonna round at this point. Okay. So I look at the number after, which is 5, and I'm gonna determine that I need to do what to the 0? Huh? Make it a 1. But this number of 1,005 is not going to turn to 101. Okay, because no way you can go from a number in the thousands to a number in the hundreds. It's going to be 1, 0, 1, and then a 0. And the reason why is because basically, just because you're rounding three significant figures doesn't mean that that's going to change this number that's in the thousands to any number that's not in the thousands, okay? You're just rounding to three significant figures. So if anything, this 0 is like a placeholder, so you don't lose the essence of what that number was. If it was a number in the thousands, when you round a three significant figure, it's still a number in the thousands. Okay? Let me do another one like that. Say you're looking at an example and it says the population of a city is 23,465 people. Okay? And they want you to round it to three significant figures. Okay? To give an approximation of about how many people are in this town. Right? Where do you start your count? At the 2. So to round to three significant figures would be 1, 2, 3. Am I going to round that 4 up? Yes, it is. But it's not going to be 235 people in this town. No, it's going to be how many? 23,500. About that many people. Okay, so those zeros are like placeholders so you don't lose the essence of what type of number it was. Does that make sense? And then the last one, correct the two significant figures. Where do I start my count? At the 2. So there's 1 and 2. So I stop here. And then I look at the next number to see if I round. Do I round?
Yeah.
So that 9 is going to end up rounding up to the next whole number. So what is this decimal actually going to be?
0.3.
Careful. 0.30. Two significant figures. So again, you still need to have that 0 because technically, had this not been a 9, it would have been a number there. But because it was a 9 and got rounded up, it's still that 0 there. You don't need any placeholders for the numbers after the decimal. You don't need that. It's only for the ones that are before the decimal. Question on that. All right. Let's look at. Okay, we're gonna look at. Let's see what we got left here. Okay, I already told them. No, I didn't say that. Again, if it doesn't tell you how to round, you always do three significant figures. Make a note of that. You always do three significant figures if it doesn't tell you how to round. Make a note of that. We're going to look at this example now. We're going to practice using our calculator. Part A says we're going to write down the value of R giving the full calculated display. So we're going to use our calculator here, get some practice, and then we're going to write our answer correct, Mr. T, to three significant figures and then two significant figures. Okay? So, you guys think you got it on your own? You want me to do the calculator part with you?
You got it.
You want to try? Okay. Okay, so I have to do this. Okay, so I want to do 12.4 to the third. Now, we know that if you press the x squared button, it gives me a 2. But if I want a third or a fourth power or fifth power, we're going to press the caret button. And for me, it goes automatically into the exponent. For some of you guys, if you're using one of my calculators, it doesn't automatically do that. You might get the actual, you might actually get this thing. Okay, that's fine. Nothing wrong with that. You just type in a 3. The only issue with doing it this way is that you have to press the right arrow button over to get out of the exponent. Okay? If you have the one that's over here on the screen, you don't have to worry about that. You just keep typing. Now we're going to divide it by 2.1 plus the square root of 3. Now we want the calculator to divide that entire numerator by the entire denominator. So what do I need to put? Parentheses. You've got to put parentheses around the entire denominator. So, real quick, if you did this, I want to show you another cool trick. If you were able to type everything in, but you forgot to include your parentheses, this is going to be so helpful, especially when you get to those long problems where you have to do a lot of work in your calculator and say you forget a negative button. Instead of pressing clear and trying all over again, just go over to where you need to put the parenthesis in. You press the second button, and then you press the delete button. Above the delete button, it says INS. That's short for insert. I need to insert in an open parenthesis. And then that way, when I get to the end, I can just close it. Alright? So second delete allows you to insert in things that you forgot. Alright? So when you click enter, you got this? Awesome, whatever. So let's write down the full calculator display. Write that down.
So, Fred, it's the, yeah, but then it's straight.
Okay? It's the full calculator display. That's the easy part. Now let's round this to 3 significant figures and 2 significant figures. You guys do that. So when you round this to 3 significant figures, where do you start? Which one? First one. So you have 1, 2, and 3. So am I going to round that 7 or keep it the same? So what? 498. That is your answer to 3 significant figures. But what about the round of the 2 significant figures? Now, am I taking the rounded answer or am I going back to the original? Always go back to the original. If you ever have to use an answer to answer like a follow-up part, you always go back to the original answer. Okay? So we're going to have the 4 and the 9, so we're going to stop at the 9. Do I round the 9 up? Which means that I'm going to essentially round what up? The 4, so my final answer is going to be 500 because I still need that placeholder for the 7 because I can't go from like 497 to just 50. Okay? No, this is still 2 because technically had that not been a 9 there, we would have had, like say it was an 8 instead, we would have had a place for that. But because the 7 cost a 9 to round up, this is 2 significant figures. Questions? Always go back to your original answer. Here's another trick. I'm teaching a lot of different tricks, but this next one's my favorite. Okay? Okay. Say I wanted to take this problem again and maybe add something extra to it. Like the one right up at the 12.4 to the third. If you press second and then the negative button, no. Second and the enter button, my mistake. It basically copies the previous line. Yeah. So second enter allows you to pull up the previous line. Okay? There you go. Some of the free. Awesome. Okay? Questions about anything we talked about so far? Rounding or number sets or anything like that. Okay. I want to skip those 2 examples because I want to make sure we get through this last little bit, which is estimation. Okay? Estimation is kind of like rounding. But an estimate of a quantity is an approximation that is usually used to check the reasonableness of your answer. To estimate an answer, you round all numbers involved to 1 significant figure. What's the important part of that top piece? You round all of it to 1/6 figure when you're trying to do an estimate. Okay, so if it ever says to estimate the number of seats in the theater, okay, that means that you are rounding to one significant figure. Okay, and even though it didn't tell you how to round, it said estimate. We're making an estimation. We are rounding this to one significant figure whenever we make an estimate. Okay. So a theater has 98 rows. Each row has 23 seats. Estimate the number of seats in the theater, because you're not going to sit there. You're not going to be like, okay, now how? Okay, if I do 98 times 3, okay, old school, long. Make it easier on yourself. We know that we have to multiply these two numbers, right? So why not estimate the number of rows and estimate the number of seats to get an estimate of how many seats are in the theater? Estimate 98. It's 100. We round to one significant figure, which would be the 9, but the 8 costs the 9 to round up. Estimate 23. What's that? 20. And I tell you, 100 times 20 is a lot easier than multiplying 98 by 23. And plus it's an estimate. Approximation, about, close to. What's 100 times 200? 11. 2,000 seats. There are about 2,000 seats in the theater. You see how estimation works? You do one significant figure for your numbers, and because we're trying to figure out how many seats are in the theater, we basically multiply the rows by the number of seats. And that's how we end up getting an estimate. Okay? Let's look at this last example. Then I'll give you guys your homework and a chance to get started. I'm quite curious to see if anybody remembers how to do these problems. Did you round to one significant figure for the distance you had to travel?
Yes.
So you made that 500? And we know that distance equals rate times time. And we're looking for our rate, so this is basically 6R. We solve by just dividing. Okay, 500 divided by 6 is 8 point what? 83.3. So you're basically looking at flying at 83.3 miles per hour, about to make sure you can make it there in time. Huh? No stoplight, straight highway, no traffic or construction.